Hello everybody, welcome into another lesson. So today we are going to talk about classifying conic sections. So in this lesson we'll be given some quadratic equations and we have to classify what type of conic section it is and then the important characteristics about it. So here we have 9x squared plus 4y squared plus I have a 36 twice. That should be a 36x. Good grief. Plus 36x minus 24y plus 36 equals 0. Well, it's definitely kind of jumbled up. So what you want to do is get all your variables together first. So this should turn into 9x squared plus 36x plus 4y squared minus 24y. Now that 36, I would get rid of it out of the left. You'll set that equal to negative 36. Now, of course, you're going to, with your variables, factor out the common coefficient. So 9x squared and 36x, you have a common 9 that'll factor out. So that'll be 9 times x squared plus 4x. Plus with your y squared, 4y squared and minus 24y, you have a common 4 that'll factor out. So plus 4 times y squared minus 6y is equal to negative 36. Alright, so next step is, again, like before when we did some of these, we want to complete the square. So you'll take 9 times, you have x squared plus 4x, and then completing the square you would have a plus 4. Plus you'll take now your 4 times your y squared minus your 6y, and then if you complete the square on this you would get plus 9. All that equals to negative 36 plus your completed square from the results from the left-hand side. So if you take 9 times 4, you'll add 36 over on the right-hand side. Then if you take 4 times 9, you'll add another 36 on the right-hand side. So on the left, this will factor into 9 times x plus 2 quantity squared plus 4 times y minus 3 quantity squared is equal to the right side. That would give you positive 36. Well, this is really starting to look like an ellipse, isn't it? If we were to classify this, which means then this is definitely an ellipse. So we got that part down. So we can identify this being an ellipse because of the form it's in, but the right side needs to equal 1. So we divide both sides by 36. You should get x plus 2 squared over 4 plus y minus 3 squared over 9 is equal to 1. So we definitely have an ellipse. Now let's figure out which axis is the major axis. Well, the number below the y term is bigger, so the y-axis is the major axis. So we have that. So that means then the major axis is y. Next, let's figure out the center. What's the center? Well, that's just going to be at the point negative 2, positive 3. That's your center at negative 2, 3. And then let's figure out, let's see where your vertices are. So the y-axis is major, so your a squared equals 9, which means a equals plus and minus 3. So to find your vertices, take your center coordinate, take your 3 coordinate of your center, first subtract 3, you would get a vertex at negative 2, 0. Then if you add 3 to 3, you would also get another vertex at negative 2, 6. And now figure out your co-vertices. That means your x-axis is your minor axis, so b squared equals 4, so b would equal plus and minus 2. So your co-vertices, you're just going to take that negative 2 from your center coordinate. First subtract 2, you'll get a co-vertex at negative 4, 3. And then if you add 2 to negative 2, you'll get another co-vertex at 0, 3. And then last but not least is the focus. So that means c squared for an ellipse is a squared minus b squared, which would end up equaling 9 minus 4, which would equal 5. So that means c equals both plus and minus the square root of 5. So your foci deal with the major axis. Your y-axis is the major axis. So your foci will be at the point negative 2 for your x, but you'll take that 3 and add both plus and minus the square root of 5. So your foci can be found at negative 2, then 3 plus and minus the square root of 5. And then if we were asked to graph this with all this information, we could certainly do that. I got more. All right. We have x squared minus 4y squared plus 3x minus 26y minus 30 equals 0. All right, so x squared minus 4y squared plus 3x minus 26y minus 30 equals 0. Well, get all your variable terms together, so you'll have x squared plus 3x minus 26y, minus 4y squared. We want to do the squared first. Minus 26y. Now that negative 30 needs to go out of the left-hand side, so that would equal positive 30 on the right-hand side. Okay, now we're just going to deal with completing the square. So, good news is for the x, your leading coefficient is 1. So, this will be x squared plus 3x. Now, half of 3 is 3 halves. You square that, you would get plus 9/4. Now, notice with the y's, however, 4 and 26 don't factor evenly. But to complete the square, you still have to factor out the leading coefficient. So we got to factor out all that. So that'll be minus 4 times, you got your y squared. So of course this would become positive 26 over 4, which reduces to 13 over 2 y. So this would be 13 over 2y. If you take half of 13 over 2, you're going to end up getting 13/4. You square that, you get 169/16. That's going to equal 30 plus a big mess. 30 plus 9/4. Plus if you take negative 4 times 169/16, that'd be minus 169/4. So we have a big mess here. So this is going to simplify then into, on the left side, this will become x plus 3/2 squared minus 4 times y plus 13/4 squared. Alright, would equal the right hand side. Well, 30/4 in terms of 30 in terms of fourths is 120/4, so then this would be plus 9/4 minus 169/4. By now, this should be starting to become clear that we're dealing with a hyperbola, right? We're dealing with a hyperbola based on the type of equation. So we have clearly identified a hyperbola based on what we're dealing with here. But let's get into more specifics. So the right-hand side would simplify more. So this would be x plus 3/2 squared minus 4 times y plus 13/4 squared equals, so 129 minus 169, that's negative 44, so this would just be negative 10. The right-hand side simplifies into negative 10. Well, it would almost look like this is a hyperbola with your major axis being your x-axis, but that's actually not the case. Not at all. Because you have a negative 10 on the right-hand side, you have to make the right-hand side equal to 1. So what this is going to turn into is you'll actually make the y-axis the leading axis. So you would end up having 4 times y plus 13/4 squared all over 10 minus the x plus 3/2 squared all over 10 equals 1. So definitely the y-axis just became your major axis. So the y-axis is major. We figured that out. Alright, so the only thing left to do now is simplify this first term. So we have to divide both numerator and denominator by 4 in order to make this a similar expression, but with a coefficient of 1 in the denominator. So this would simplify into y plus 13/4 squared all over, now we have 10 divided by 4, which would be 5/2. Right, so we would end up having 5/2 in the denominator, so then this would be minus x plus 3/2 squared all over 10. Alright, is equal to 1. So we have now the correct equation for this hyperbola. So the center of this is going to be at the point negative 3/2, negative 13/4. Yeah, this just got very messy very quickly, didn't it? Now, the y-axis is the major axis, so that means your a squared equals 5/2, which means your a equals plus and minus the square root of 5 over 2 is the same as the square root of 5 over the square root of 2 is the same as plus and minus the square root of 10 over 2. So now for your vertices, you're going to take the y-coordinate, since the y is the major axis, and add both plus and minus the square root of 10 over 2 to that negative 13/4. So the vertices can be found at negative 3/2, and then let's see here, then negative 13/4 plus and minus the square root of 10 over 2. Yes, this just got a bit messy for sure. Now, we also got to deal with the business of the foci. In a hyperbola, c squared equals a squared plus b squared, which would mean we're going to have 5/2 plus 10. So that would be 25/2 is c squared, which means c equals plus and minus. Well, that would be 5 over the square root of 2, so that would be plus and minus 5 times the square root of 2 over 2 for your c, giving you your foci. Since y-axis is your major axis, your foci would be at negative 3/2 and then negative 13/4 plus and minus 5 times the square root of 2 over 2. So we found all the information we need now to go ahead and graph this hyperbola if we were asked to do so, but we weren't. So sometimes this can get a bit messy. This absolutely can. Alright, we have 4x squared minus 9y squared plus 18y plus 3x equals 0. This one doesn't look so bad. 4x squared minus 9y squared plus 18y plus 3x equals 0. We'll still go ahead, get your equation, get your variables together. So you'll have 4x squared plus 3x minus 9y squared plus 18y is equal to 0. So you got your variables together. Now for each of these we need to factor out the leading coefficient. So for your x terms, factor out the 4. You'll end up getting 4 then times the quantity of x squared plus 3/4 x minus your 9 times, then you'll get your y squared minus 2y is equal to 0. Well, I think it's evident now we got to complete the square. So we'll take 4 times the quantity of x squared plus 3/4 x. So if we complete the square on this, that's going to end up being 9/64, because half of 3/4 is 3/8. If you square that, you get 9/64. So that would be plus 9/64 minus 9 times, let's see, y squared minus 2y. This would be plus 1. So now we got to take our results from the left side, add them to the right hand side. So 4 times 9/64, that ends up becoming 9/16. Then negative 9 times 1, that's minus 9. So the left side will factor into 4 times the quantity of x plus 3/8 squared minus 9 times y minus 1 squared equals the right hand side. So what is 9 times 16? That's 144. 9 minus 144 Wow, that's going to be crazy. That's negative 135/16. So we have negative 135/16 on the right-hand side. This is definitely a hyperbola. If you would have said hyperbola, you'd be correct. This is a hyperbola. Now, it would look like, again, that your major axis would be your x-axis, but take note that the right-hand side's negative. So when you divide by the negative, you're going to end up flipping this around to where the y-axis becomes the major axis. So we can establish that right now. The y-axis is your major axis. So this hyperbola will have y-axis symmetry. Let's go through and divide both sides by negative 135/16. So you would get 4 over x plus 3/8 squared. Actually, this is going to flip around here. Remember, we're dividing by a negative. This would end up being 9 times y minus 1 squared over 135/16 minus 4 times x plus 3/8 squared over 135/16. What a mess, right? So what started looking not too terrible became terrible really quickly. Make sure I get nothing important here. Okay. Well, the right-hand side equals 1, but we need to simplify the numerator so we get the correct lengths of the axes. So the first term we have to divide by 9. So let's see. If we do that, you end up getting y minus 1 squared all over 135 over, so you take 135 over 16 divided by 9, that'd be times, so that'd be 135 over 144 minus your next one, that's going to be x plus 3/8 squared all over 135 over 64. All right, so we have a real mess here. Now, definitely then our center is going to be at negative 3/8 positive 1. That's our center. But the y-axis is the major axis, so 15 times 8 is 120, 15 times 9 is 135. Because we're going to have to take, okay, so a squared equals 135 over 144, which has to mean that a equals both plus and minus. We know the square root of 144 is 12. But the square root of 135 would actually break down into, so 15 times 9 is 135. That would be plus and minus 3 times the square root of 15. That would break down into that. So your vertices can be found at negative 3/8, and then 1 plus and minus 3 times the square root of 15 over 12. So very messy. And then last but not least, we're going to do your foci. So c squared equals a squared plus b squared. So that's going to give you 135 1/44 plus 135 64. This, I fear, is really going to become messy. Oh, good Lord. Oh, good news. Well, we have some good news here. They can get a common denominator of 576. So, alright, so 576 divided by 140. So we have to multiply the first fraction, numerator and denominator, by 4. So that would be 540 out of 576. Plus, we got to do the next one here. So, let's see. 576 divided by 64 is 9. So we have to multiply numerator and denominator by 9. That'd be 1,215 over 576. So let's add those together. You get 1,791 over 576 for your c squared, mind you. Now, that means that c is equal to plus and minus. The good news is your denominator factors perfectly into 24 when you take the square root of 576. But 1791, I don't think we're going to get so lucky. No, we're definitely not. But it does break down into the square root of 9 times the square root of 199. So that would be 3 times the square root of 199 in the numerator. So your foci, since the y-axis is the major axis, you'll have negative 3/8. And then you'll have 1 both plus and minus 3 times the square root of 199 over 24. So yes, very awful problem there. What started out looking relatively simple turned pretty bad pretty quickly, didn't it? Alright, I think those are all the hyperbola examples we're going to do. I'm not going to do any more hyperbolas for this lesson, no. That was not pretty. Alright. So we have x squared plus y squared minus 10x minus 2y plus 10 equals 0. Well, let's get our variables together first. So you'll have x squared minus 10x plus y squared minus 2y. Now get rid of that 10 out of the left-hand side. That'd be equal to negative 10. So good news is leading coefficients on both your quadratic terms are 1. So let's complete the square on each of these. So x squared minus 10x, if you complete the square, you should get plus 25, would actually then equal, then you'd have plus, you would have the y squared minus 2y, well, this would actually turn into plus 1 equals negative 10. Now you complete the square, so you got to add both the results from here to the right side. This would actually turn into plus 25 plus 1. So this would factor into x minus 5 squared plus y minus 1 squared equals 16. Well, what do you notice here? You have no denominator on your variables, or you could argue they both have a denominator of 1, meaning that both axes have the same length. Then you have the right side equal to 16. So actually this is a circle. We actually have a circle for this one, so this isn't so bad. We got a circle, so what's the center of the circle? The center in this case is going to be 5, 1. The center is 5, 1, and then all we have to know now is the radius. Well, the right side is the radius squared. R squared equals 16, so your radius is 4. So this is a circle with center at 5, 1 and a radius of 4. So that one wasn't so bad. Much easier to deal with. All right. How about this one? X squared minus 2x plus 8y plus 9 equals 0. Okay, so x squared minus 2x plus 8y plus 9 equals 0. Well, what do we notice right away? Only one of the variables is quadratic. Now, what type of conic section only has one quadratic variable and the other linear? That'd be a parabola, right? So if you said this was a parabola, you'd be correct. This conic section actually becomes, this is a parabola. So what you want to do in this case is go ahead, get your y and your constant term over to the right hand side. So this should turn into x squared minus 2x equals negative 8y plus 9. I'm sorry, negative 8y minus 9, excuse me, since we subtracted. Now, we still want to complete the square on the left-hand side, so this would turn into x squared minus 2x plus 1, but we got to add that 1 to the right-hand side. That would give you negative 8y minus 8. So this should factor then into x minus 1 squared equals negative 8 times y plus 1. So we have this now the equation of a parabola in standard form. Now, which axis does it have symmetry with? Remember, it's always the linear variable. So this has y-axis symmetry. So this parabola has y-axis symmetry. Now, what's the vertex of this parabola? So that's going to be at 1, negative 1. That's your vertex, is at 1, negative 1. Now we need to find two more pieces of information. The directrix and the focus. Well, remember, 4p equals that coefficient of the right-hand side. So 4p equals negative 8. That means p equals negative 2. Well, to find your focus, you take that p and you add it to the to your vertex coordinate, and if it's y-axis symmetry, you'll add that to the y-coordinate of the vertex. So you will then end up having your focus. If you add -2, you'll end up having the focus at 1, -3. Now to get your directrix, all you do is you negate that p. So the directrix will be then at y. Since it's got y-axis symmetry, it'll be y equals -p. Well, -2 is +2. No, it would be +2 plus that -1. It'd be y equals 1. You take the negative of p and add to -1, you would get y equals 1 for your directrix. So you have a parabola with the vertex at 1, -1, y-axis symmetry, focus at 1, -3, directrix at y equals 1. Let's see if we can find another parabola example real quick, and then we'll be done with the lesson. All right. Yes, I found such. So let's see. We have 2y squared minus 8y minus 4x plus 10 equals 0. So we have 2y squared minus 8y minus 4x plus 10 equals 0. Again, notice how only one of the variables is quadratic. That's going to be your y variable. Your x variable is linear. So right away we can spot a parabola. So this would in fact be a parabola. And furthermore, since the x variable is linear, we know it's going to have x-axis symmetry this time. So this parabola has x-axis symmetry. Now, what you're going to want to do, keep your y variables together on the left side, move your x variable and your constant out of the left-hand side. So this would turn into 2y squared minus 8y equals 4x minus 10. Well, let's see here. Now we can complete the square. Well, first let's factor out a common 2 on the left-hand side. So that'll be 2 times y squared minus 4y. Completing the square on y squared minus 4y, that would give you plus 4. So this is going to then equal 4x minus 10, but we actually have to, since we completed the square on the left-hand side, we got to add the result to the right. 2 times 4 is 8. So then you end up with 2 times y minus 2 squared equals 4x minus 2. Well, notice you can divide, and you want to do this because your quadratic term, you want to have a coefficient of 1 outside of the parentheses. So divide both sides by 2, you get y minus 2 squared equals 2x minus 1. And then we got to factor out that 2 from the x on the right-hand side. You end up getting y minus 2 squared would equal 2 times x minus 1/2. Now we got the standard form for an equation of a parabola with x-axis symmetry. So let's find out what the vertex is. The vertex, of course, would be at 1/2, 2. The vertex of this parabola is at 1/2, 2. Now, we still have to find the focus and the directrix. So let's find P. Well, we know 4P equals 2, which would have to mean then that P equals 1/2. And this happens to have x-axis symmetry. So to find the focus, you'll add the P to the x-coordinate of the vertex. So your focus, if you add half to half, will be at 1, 2. Now to find the directrix, you add the negative of P to the x-coordinate of the vertex. So you'll have a directrix. Since it's x-axis symmetry, it'll be x equals 1/2 minus 1/2, which would be 0. So you have a directrix at x equals 0. So yes, we just did quadratic equations basically that all are equations of conic sections. It's just learning how to identify them. Parabolas probably start out the easiest to identify because one of the variables is only linear and the other one's the only quadratic one. The other ones you usually got to do a bit of factoring and completing the square to figure out what form it's going to take. And then you can either determine if it's a circle or an ellipse or a hyperbola. So that's it for this lesson. Next lesson we are going to talk about solving a system of quadratic equations. That'll be a 3-part lesson where this next lesson specifically will be involving the intersection of a conic section and a line. So I hope everyone has a great day. Take care.